All right, this video is to help you answer the absolute dating practice worksheet number 3. The first two questions are from your notes. The third question says, if we start with 400 atoms of a radioactive substance, how many atoms would remain? And then it says after 1 half-life, 3 half-lives, 2 half-lives, and 4 half-lives. So I think what they're looking at is something like this. And it says we're starting with 400 parent atoms. And this would be 1 half-life. This is the rock that's left after 1 half-life. 400, you take half of that, it becomes 200. So after the second half-life, this is the second half-life, you would have 100 parent atoms. After the third half-life, you would have 50 parent atoms. And after the fourth half-life, you would have 25 parent atoms. The way I calculated that was I took 400, divided it by 2, to get 200. I took 200 and divided it by 2 to get 100, and I continued to do that for each of them. This bottom part of the first page asks you to look at this graph and answer these questions. So the first question says, how long is each half-life for carbon-14? Remember what a half-life is. A half-life is the time it takes for half of the parent to turn to daughter. So in this case, you start out at 0 years with 100% parent. How old is the rock when it's at 50%? Well, this bar looks like it's at 50%, so that's got to be 1 half-life. And this bar is at 25%, so it's at 2 half-lives. And this bar is at 12.5%, so that's 3 half-lives. That's the same percents we calculated in class. The percents are 100% as a brand new rock. After 1 half-life, there's 50% parent. After 2 half-lives, it's 25% parent. After 3 half-lives, it's 12.5% parent. After 4 half-lives, it's 6.25% parent. And these numbers are all in your notes. The next page of worksheet number 3 is word problems. And it gives you this information. It says, use this graph to answer the next 3 questions. And what we've done is we've answered number 10 for you. So let's go over how we did number 10. It says if you started with 8,000 atoms of radium-226, how many atoms are left after 3,200 years? So we filled out the chart. We have 8,000. The parent gets halved each time, 4,000, 2,000, 1,000, 500, 250. And then we figured out how much daughter there is. Remember how to figure out the daughter. If the total is 8,000, daughter is going to be 8,000 minus the parent. 8,000 minus 8,000 is 0. 8,000 minus the parent, which is 4,000, is 4,000. 8,000 minus 2,000 is 6,000. 8,000 minus 1,000 is 7,000. 8,000 minus 500 is 7,500. 8,000 minus 250 is 7,750. How many half-lives old is it? 0, 1, 2, 3, 4, 5, just like we did in class. And how old is it? Well, after 0 half-lives, it's 0 years old. After 1 half-life, it's 1 times the half-life. The half-life of radium-226 is 1,600 years. Look, I found it right here. Radium-226 is 1,600 years. So after 1 half-life, it's going to be 1,600 years old. After 2 half-lives, it's 2 times the half-life. 2 times 1,600 is 3,200. After 3 half-lives, it's 3 times the half-life, or 3 times 1,600, which is 4,800. After 4 half-lives, it's 4 times the half-life, which is 4 times 1,600, which is 6,400. And 5 times the half-life is the age of this rock, which is 8,000. So let's go back to the question. It says, how many atoms would remain after 3,200 years? So this is the one we're talking about, 3,200 years, because that's how old that rock is. How many atoms of parent are left? There it is, 2,000 atoms of parent are left after 3,200 years.